Hello everyone, welcome back to the channel. In today's video, we are diving deep into agentic AI on AWS. We will start with a quick look at Amazon Bedrock, what it is, how it works, and then jump into one of its newest and coolest features, Amazon Bedrock AgentCore. We will break down the differences between the two and walk through their interfaces. We have also got a practical hands-on demo at the end. We will see how to build a smart agent that talks directly to the Kubernetes cluster using our own MCP server. If you saw our last video, we did something similar with the custom agent, MCP server, and Kubernetes cluster all running locally. This time, we are going fully cloud native to showcase the power of Bedrock and how seamlessly it connects with your infrastructure. So first, let's understand what is Amazon Bedrock. Amazon Bedrock is a fully managed serverless platform that gives you access to large language models from industry-leading providers like Anthropic, Meta, and many more, along with Amazon's own models like Titan and the newly launched Amazon Nova. You don't need to manage any infrastructure or worry about model deployment. Everything is handled for you securely and at scale through a single unified API. You can start using these models for tasks like text generation, summarization, Q&A, and more without being an AI expert. But Amazon Bedrock goes a step further. It lets you build intelligent agents on top of these foundational models. With Bedrock agents, you can create systems that accept user input, run reasoning logic using instructions you define, take actions via action groups that connect to external systems like databases. While there is certainly some configuration involved, adjusting parameters, crafting a well-designed prompt for the agent, and setting up your Lambda function, Bedrock significantly abstracts away the complexities. It eliminates the heavy lifting of building your own agent from scratch and managing its orchestration logic. This empowers you to focus on defining the agent's capability and goal rather than worrying about the underlying code. So how does Bedrock agent works? You define prompts and instructions, create action groups with well-defined schema, and let the agent handle the orchestration, including tool selection, memory, and reasoning. And that's all. To make your agent even more powerful, you can integrate Lambda function as part of your action groups. This allows the agent to trigger backend logic, query databases, call external APIs, even update resources in your AWS environment. You can use Bedrock agents for conversational customer support, internal tool automation, data retrieval bots, DevOps assistant, workflow automation, and much more, all while relying on Bedrock's integrated foundational models to power the natural language understanding. So to summarize, Amazon Bedrock is your one-stop solution for building Gen AI-powered application. You get access to the top foundational models from multiple providers. You can build agents that go beyond simple chat, integrating logic and actions, and you don't have to manage any of the infrastructure or scaling. In short, Bedrock lets you build and scale generative AI application quickly, securely, and with production-ready performance. Now that we understand Amazon Bedrock and how you can use it to build agents with foundational models, let's move on to something more advanced and developer-centric, Amazon Bedrock AgentCore. Amazon Bedrock AgentCore is a new capability that gives developer full control over the AI agent's orchestration logic. While Amazon Bedrock Agent offer a low-code way to create intelligent agents using foundational models and prompt instructions, AgentCore is for the builders who wants to write custom reasoning logic in code, host their own agent runtime, use any LLM, not just the one provided in Bedrock, and fully control how the agent plans and execute actions. Key features of AgentCore: custom agent hosting. You write your own agent code, package it in a container, and store it into ECR. AgentCore then invokes the container to run your agent logic. Flexible model use. Unlike Bedrock Agent, which use only Bedrock built-in models, AgentCore lets you connect to any LLM, even models from OpenAI, Google, or any other which is not hosted in the Amazon Bedrock, as long as your container handles the integration. Tools use an API. You can define tools, that is functions your agent can invoke, and use structured reasoning via function calls, OpenAPI schema, or other mechanism, all defined by your own orchestration logic. Fine-grained orchestration. With AgentCore, you control the orchestration, whether the agent follows chain of thought reasoning, tool chaining, or anything custom. How to deploy agents in AgentCore? You can deploy your agents using agent runtime, containerize your agent code, and store in ECR. AgentCore invokes the container via endpoints to run your agent logic, and you can also access the agent's performance. So now let's go through Amazon Bedrock interface. We will mainly see how we can explore catalog here, and we will see how we can build agents. We can explore models from model catalog, and here in the left hand side we can see all the providers which are available in the Amazon Bedrock. Most popular ones are Anthropic, Meta, DeepSeek. You can see all these are available along with Amazon own Nova and Titan models. So whenever we go here in the model catalog, you will see that models are available to request. What does this mean? This means that these models are not yet available for direct use. First, you will need to request for the access, and once access is granted, then you can use these models into your agents. So let's go to the agents and see how we can create agents and how we can request for the models. So to create agents, we need to go into the agents. And here you can see I have already an existing agent, which is Kubernetes agent. To create a new agent, we can click on create agent. And here you will need to provide name of your agent, description, which is optional. And also you can select this enable multi-agent collaboration. So once you click enable multi-agent collaboration, you can create fleet of agents, but for this time we will just go with single agent. Here in this page, you just need to provide the agent name, description, agent source, resource role. You can select an existing role, or you can create a new service role. You can select the model from here. You need to provide instruction for the agent, which means you need to provide the prompt for the agent here. And then you can add your action group. So action group is basically the tool through which you want to interact with other tools. So action group is basically something through which you can interact with other tools. And in Amazon Bedrock agent, you can interact with other tool using Lambda functions. We will see when we go inside. You can also select enable or disable memory. So if we enable the memory here, then the agent will be able to retain the conversation. We can attach the knowledge bases here. Like if you want to attach your organization's S3 or databases, so that your agent can iterate over those knowledge bases and then provide output based on those knowledge bases, then you can attach your knowledge bases. You can edit the guardrail details. You can edit orchestration strategy. So we can modify all these details. So you can see here, like in Amazon Bedrock agent, you cannot create your agent, but you can configure an existing agent using your prompt and action group. On the right hand side, you can see a test agent here. So once your agent is created, you can directly test your agent from the UI itself. Now, how we can select a model? So once we go here, you see I have this one model available to select from Amazon, but what if I want to select other model, for example, Nova Premier 1.0? So to do that, we will need to go to request access, and then here we can go to modify model access. Then we can select the model which we want to request. So for example, if we want to request maybe Nova Pro, we can select here, and then we can click on next. And here in this step 2, you see add use case details for Anthropic. So as this is not an Anthropic model, so we don't need to fill the use case. If we will select an Anthropic model, then we will need to provide additional detail for the request. So let's submit and see if it is there. So model access update submitted, and now we can see if it was granted. So we can go here and we can see it's already granted. In case if we will request any model from Anthropic, let's see what it says. So as you see here, it's asking for more details, use case details. So you basically need to provide your company name, company website URL, and other details to request for Anthropic models. So as we have requested already model for Amazon, let's refresh the page and then come back again. So let's do it. Let's refresh once. Okay, now you will be able to see this, and we can select and apply. So this is how you select a model and apply to your agent. Here in the instructions for agent, you need to provide the prompt for your agent, and in the action group you can add an action. And here you will see basically you have two types of action group. In one you can define function detail, in the other you can define API schema, and here in the invocation you can select a Lambda function. If there is no Lambda function, you can quickly create one, and then you will need to select your Lambda function and the version, and then you can define your inline schema. So let's see, I had already created one for the Kubernetes engine, Kubernetes agent, and we can see how it is defined. So let's go to this one, and so for this agent I had selected a model which is command R+, because that was suitable for my use case, and I have selected an existing service role, and in the instruction I have given a prompt, and in the action group I have created an action. So here I have selected API schema, and I have selected a Lambda function which I created earlier, and then I defined inline schema where I'm calling the path for the Lambda function. So this is how we define or configure our agent. And in the Amazon Bedrock, as I said, we cannot create a new agent from scratch. We cannot code an agent completely. Rather, we can utilize the agent capability and configure the agent using prompts and action groups. So this is how it works. And in the AgentCore, which is different from Amazon Bedrock Agent, it is different. Like there, you can select your created agent. Like you can write your own code, you can write your own agent, and then you can orchestrate your agent on the AgentCore. We will see when we go to the AgentCore UI. So for now, this is all about how we can create an agent. Okay, so now let's go through the Amazon Bedrock AgentCore UI. Amazon Bedrock AgentCore is a serverless platform that lets you securely build, run, and scale custom AI agents with modular tools like memory, identity, code execution, and web browsing. So now let's go into the agent runtime and see how we can host our custom applications. To host our applications, the first criteria is you need to have your application containerized and stored in Amazon ECR. So if you have your code containerized as Docker images, then you can pull it from Amazon ECR, and then you just need to set the permission and few other configuration, and you can host your agent. And apart from the agent runtime, we have some other options too, like built-in tools, gateway, and memory. Now let's see what is built-in tool. In AgentCore, you can define custom tools that your agent can invoke at runtime. First is code interpreter, and the second is browser tool. Code interpreter allows your agent to securely write and execute code in real time. So if you want your agent to do calculation, parse data, or even write small logic blocks on the fly, it can. And browser tool and through browser tools, your agents can control a real browser session. So instead of just calling APIs, your agent can literally navigate a website, click buttons, fill forms, or extract information from live pages. It unlocks complex web automation through natural language. So Gateway in AgentCore lets you connect your agent to external tools and APIs securely and at scale. And finally, one of the coolest part of AgentCore is memory. In regular chatbots, memory is usually short-lived, but in AgentCore, you can create persistent, evolving memory for your agents. So in summary, what can you customize in AgentCore? One of the best part about AgentCore is that you are in full control of the runtime. You can attach gateways for external tools, add built-in tools like the code interpreter or browser, configure memory and identity modules to personalize behavior, and even define your own reasoning logic or prompt orchestration inside the agent code. Now let's see what is the difference between tool invocation in AgentCore and Bedrock Agent. So in Bedrock Agent, you define action groups, each representing one tool. Each action group must point to a Lambda function. You define an OpenAPI schema that maps to a Lambda input and output. When the agent decides to call a tool, Bedrock invokes the Lambda automatically. You can't directly integrate with other AWS services like S3, DynamoDB, or external APIs unless you do so within the Lambda function itself. But in AgentCore, there are no built-in action groups. You write the orchestration code yourself. From inside your containerized agent, you can invoke any AWS service via Boto3, a Python SDK, like DynamoDB, S3, SageMaker, Bedrock, step functions. Call Lambda functions directly via the AWS SDK. Call any HTTP API, including third-party services like OpenAI, Slack, Datadog, Stripe, and connect to databases, run local tools, etc. So AgentCore gives you full flexibility, but also full responsibility of coding, authentication, error handling, retries, etc. So in summary, Bedrock Agent is easy, low code, safe, Lambda only, Bedrock managed tool calls, and AgentCore is flexible, powerful, developer owned, can invoke any tool or service inside your own container logic. So now let's go through the use case which we had to build a Bedrock agent and MCP server to interact with our Kubernetes cluster. So basically the idea is users can write the instruction to agent in natural language. For example, if a user wants to ask agent that give me all the running pods on default namespace, then what agent will do is take that instruction in natural language and then it will consult with LLM. LLM will send back the response in JSON string format, and then the agent will send the response to a Lambda function, and then Lambda function will connect with MCP server. So basically here we have Lambda function in between only to connect the agent with MCP server, because we know that Bedrock agent cannot connect directly with any other tool without a Lambda function. So once Lambda sends the response to MCP server takes that JSON string and it converts that response into actual Kubernetes commands. And then that command is executed on the cluster, and then the response is received back to MCP, and MCP sends back the response to Lambda, and Lambda sends back to the agent. So this is the basic flow. In this video, we will not go through how to create a VPC cluster or subnet, all those things, but just we will see how our agent is working, what we have defined in the Lambda function and what we have defined in the MCP server code. Let's first check what our agent is doing. So this is our agent. So basically we have created a prompt. We are asking the agent, or we are giving the agent a prompt. So we are giving here like you are a Kubernetes assistant. Your primary role is to execute Kubernetes command on behalf of the user, and we are passing some instruction. So understand the user request for Kubernetes information, list pod, describe pod, get logs, all these things, and then we are asking it to convert the user's request into a JSON command and a parm dictionary, and then call the process k8 command tool with this JSON string, And once the tool returns a response, present the information from the tool's message. Output clearly and concisely to the user. Do not output raw JSON unless specifically requested. If the tool indicates an error, explain the error to the user. So this is the prompt we are sending to our LLM. Okay, and we have defined an action group here. So what this action group is basically doing is it has some API metadata defined, and then it has endpoint definition, and then a request body and a response. So I will upload all the schema as well as the Lambda function script and the MCP server script in a GitHub repo, and I will link it to the video so you can go through. So basically, in short, what this is doing is this schema describes a single endpoint service that accepts a post request and responds with either a success confirmation or an error message, depending on whether the output is valid. In short, this schema describes a single endpoint service that accepts a post and responds with either a success confirmation or an error message, depending on whether the input is valid. Okay, now let's see our Lambda function. So what our Lambda function is doing. So basically, Lambda function is receiving a request from Bedrock Agent, and it expects the agent to invoke process k8 command, and then the Lambda function is extracting the JSON command string, and then it sends an HTTP post request to MCP server endpoint with the raw command string as the body. And then once it also receives the response from the MCP once the MCP executes the command and receives a response back from the Kubernetes cluster. So this is what Lambda function is doing. Now let's see what our MCP Python code is doing. So it is exposing one endpoint, which is /mcp/execute, and that endpoint receives a JSON payload from the Lambda function. It parses the instruction and parameter, maps them into a Kubernetes API call using the official Python Kubernetes client, and executes the command, and then it returns the structured result to the Lambda function. So this is what it is doing simply, nothing more or nothing complex. And I will upload this in the GitHub repo so that you can go through in detail. We have deployed our MCP server as pods on Kubernetes cluster, so we can check. Also, we have an Nginx pod running. So now let's go to our agent and test whether it is running fine or not. So this is our agent. Let's go. Let's save and prepare our agent to make the test. So here we will write list all the running pods in default namespace. And now our agent is processing the instruction. So as you see, it gives the message, right? The following pods are running in the default namespace, MCP server and Nginx. So we can see we had these two, 2F2 and KP6. So these are the same. We can see that it gives the correct output. So this is how we can deploy our Bedrock agent to interact with the Kubernetes cluster. In the next video, we will take this a step further by implementing the same flow using AgentCore. We will build our own custom agent, deploy it on the AgentCore runtime, and explore how we can take full control of tool invocation, memory, and orchestration, giving us even more flexibility and power. Thank you for watching.